Hello everyone. In this presentation, we are going to see about a recursive function. Okay, recursive function. So, what is recursive function? A function which calls itself is called a recursive function. Okay, a function calls itself is called a recursive function. Okay, so this question is very important. You can expect this question in your semester examination. So, see this video multiple times, then only we'll get an idea. It's a little bit tricky, so I'm instructing you to watch this video multiple times. Okay, let's get started. uh, so here I have some set of informations, okay, which is helpful to us to understand about the recursive function. So here I have the code, and here I have the breakup of that, and here I have the formula for factorial, and here we have explanation about that. Okay, all right. So now, before getting into recursive function, we are going to implement recursive function using factorial. So factorial, in mathematics, we have studied, I think, so factorial. What is factorial? So factorial is nothing. So this breakup I have given here, what is factorial? For example, for 1 factorial, we have value 1. 2 factorial, you see, it is 2. So how we can break this one? So 2 into 1. So 2 into 1 is what? 2 only. Okay. Coming to 3 factorial means 3 into 2 into 1. That is nothing, 6. Okay. That result only we have here. 4 factorial is 24. So 4 into 3 into 2 into 1. That is nothing, 24. Okay. Next 5 factorial, it's 120. So 5 into 4 into 3 into 2 into 1, that is 120. All right. So this factorial we are going to perform by using recursive function. All right. Okay, now we will see the formula for this. So for this one, we have formula here. Look at this carefully. N factorial means nothing. Any number you can put in this is equal to n into n minus 1 into n minus 2 into n minus 1 and so on till 1 it has to go. This is base. So that we have here base case. So that condition I have given, if n is equivalent to 1, we have to stop. Okay, we have to stop, return 1 it is. Return 1 means it will return to this one. Okay, so while doing the code, I will give the explanation about this, how it works. So let me rub this. Yeah. All right. Okay, so n into n minus 1 into n minus 2 till which it has to go? Till 1 it has to go. That is the base. That is the end. Okay, so if you read this base case condition, the condition where the recursion stops, we are stopping here. Where here we are stopping in this case. Okay. All right. Now something we have here, return n into factorial of n minus 1. So how it works, that we will see. Okay. So we will go to the program where I have here. Let me show you the output. Yes, where is the editor? Yes. All right. Here you can see the code. Okay. So here we have the main function. Okay, we have the main function. In main function, num value we have given as 5. Okay, num value we have given as 5. Num is a variable, 5 is the value we have sent for this. In this program, we are going to find factorial for value 5. So you can find factorial for any value. So num is equal to 5. And here we have one printf statement, which prints num value, which is nothing 5, and factorial of that 5, factorial of that particular number. Okay, so factorial of num. You see this, let me explain this code. So the program execution will start from main function only, not from this. This is user defined function. So here we have user defined function. Here we have main function. The program execution will start from main function. So we have assigned 5 to the variable num. Then we have the printf statement. In this printf statement, we have the function call. This is the function call, factorial of num. So where we have factorial function, here we have. So we are calling the user-defined function. This is the user-defined function. This entire thing is user-defined function. We can call this as a factorial definition. Actually, for this function call, where we have definition, here we have definition. Okay, so we are calling this function, this entire function by this. So this is nothing, function call. Okay, this is nothing, function call. All right. So whenever the execution starts, so when the control encounters this instruction, actually this is an instruction actually, this function call calls this function along with what? Along with the value 5. So how it is 5? You see factorial of num. So in num what we have? The value 5 that we have here. Okay. So 5 will be assigned in this place. Okay. So function call, it will go along with 5. And here n value also is what? 5 only. Okay. N value is 5 only. So the signature you see, the signature means the spelling and everything you see, it is matching with this one. Okay. So this function will be called along with what? 5. So factorial of 5 here. Okay. Now what happens? Here 5 we have, and here also 5 will be substituted. So 5 is equivalent to 5. Sorry, 5 is equivalent to 1. Condition fails. So this is not going to execute. Else part will execute. In else part, what we have? Return n into factorial of n minus 1. Okay. So what I'm going to do now, let me split up the screen for better understanding. I'm trying to split up. We will see whether it is splitting up or not. No, editor is unable to do that. Okay, all right. Let me fix this. Let me take this one. I'll try. Yes. Yeah, editor, it is not getting split up in this. Okay, all right. We will try to do this. It's done. Okay, so what I'm going to do, I'm going to write in this area. Okay. Selection. A few things have disappeared. Okay, all right. Okay, so what's happening here? Look at this carefully, the return function. So when the control comes to this situation here in this part, present n value is 5, correct? So n is equal to 5, and here also n is equal to 5. Okay, so 5 minus 1 here, we have 5 minus 1. So 5 minus 1 is what? 4. So let me write here, for n, 5 it is. So 5 into factorial of n minus 1. N is equal to 5. So 5 minus 1, 4 it is. Okay. Hit enter. Now, factorial of 4 is nothing. That is a function call. Okay. Here the value changes. So factorial of 4 it is presently. Now this is a function call. It is going to call this function again. So what is the definition of this? The definition says that a function which calls itself. So this is the function which calls itself here. This condition satisfies here. So now factorial of 4 is going to assign in this place. Which place? N is equal to 4. So 4 will be assigned in this place. So 4 is equivalent to 1. Condition fails here. So this statement is not going to execute. Else part will be execute. In else part, what we have? Again, we have n into factorial of n minus 1. So let me write here. For n, we have presently 4. 4 into 4 into factorial of n minus 1. Here we have n minus 1 means 4 minus 1. 4 minus 1 is what? 3. And we have to take the previous value. 5 is remaining, right? So 5 into, we have to add here. So previous value we have 5. So 5 into 4 into next factorial of 3. This is nothing, a function call. This is a function. Again it is calling. Again it is calling. This is called a recursive. Continuously it will call again and again. So here with value 3, for n, 3 will be assigned. So function call again factorial of 3, and here 3 will be assigned. And in this case 3 is equivalent to 1, condition fails, so this is not going to execute. In else part it will execute. In else part what we have? N into factorial of n minus 1, which means 3 into factorial of 2. Okay, 3 into factorial of 2. So let me write here the previous things. I'll write here 5 into 4 into, presently we have 3 into factorial of what? Factorial of 2. Okay, factorial of 2. So after this, factorial of 2 is nothing, it's a function call. Again, this function which function will be called? This function will be called with value 2. So value 2 we have in this place. N minus 1 means here 3 minus 1 it is. So 2 will be assigned. So 2 will be assigned to n. And here also 2. 2 is equivalent to 1. Condition fails. This is not going to execute. This will execute. Now in nth value, in nth place, what value we have? In nth place we have the value 2. So 2 into factorial of 2 minus 1, which is nothing. 2 into factorial 2 minus 1 is 1. Okay, so let me write it quickly here. So the previous things are 5 into 4 into 3 into factorial, 2 into factorial of 1, right? Okay, so factorial 1 is nothing. Again, by having the value here, we have factorial 1. Again, this is a function call. Again, it is going to call this one with the value of 1, assigning the value of n, assigning 1 to the variable name is what? Variable name here we have n. To that 1 will be assigned for this. So 1 is equivalent to 1. Condition is true. Now return 1. What is the meaning of this return 1? Now this becomes true. 1 is equivalent to 1. Return 1 means it is going to return to this one only. Okay, to this one it will return. So here already we have 1. So here return 1, which returns 1 here, completely 1. This factorial of n minus 1 will become 1. So how we can write this? Here n into means 1 it is, correct? So previous values are 5 into 4 into 3 into 2 into, now we have 1. Okay, for this n we have 1 presently. That one we are going to write here. Okay, now the entire thing is over because we have entered in this. Return 1 means it is going to return 1 then stops. Here we are stopping. That's why it is base case. Base case means nothing where the infinite loop, actually here we don't have loop, we are not used loop, but we are calling the function multiple times. You can see here multiple times we are calling. So if you observe this area, factorial 1, after factorial 4 we are calling factorial 3, then we have factorial 2, then we have factorial 1. So after that we have to stop. That's why we have this condition. Okay, that's why we have this condition. We have to stop, otherwise it will continue infinite. It will continue with the many values, and there is no end for this. That's why we have this condition. Okay, so we are stopping with this one. So to restrict this infinite calls, that's why we have this condition n is equal to 1. Okay, all right. Now if you multiply this all things, 5 into 4 into 3 into 2 into 1, we will get 120 is a factorial value. Okay. All right. So this is the way this program works. So our idea is we have to implement recursive by factorial. So this program is very, very important, very, very important. And let me go to the theory part for better understanding. Okay. So here we have the code, that code I have explained for you. And here how the code works that we have here in the middle. Okay. Let me highlight with some other color. This is how code internally it works. And here we have the factorial for 1 to 5 numbers. And here we have the factorial formula. And here we have the explanation. So coming to explanation, you see a recursive function is a function that calls itself directly or indirectly to solve the problem. The given problem is recursive function, factorial problem. The given problem is that we are going to solve. Okay, directly, indirectly, don't bother about that. Some in some programs we have some indirect call also. Okay, that and all no need presently. You focus on what is recursive function according to our syllabus. This is enough. Next, it breaks down a complex problem into smaller, more manageable subproblems, solving each recursively until the base condition is met. Base condition is what? Base condition is if n is equivalent to 1. Until the base condition meets, that's the main thing we have to understand. This base condition ensures that recursion stops and prevents infinite loops. Here we have infinite loops. See here you can see it is infinite. 4, 3, 2, 1. It will go. If you don't have this condition, it is infinite. It will take multiple numbers and it will proceed. Okay, that's why we have this condition, base condition, that is base case. So key components, base case and recursive case. Recursive case is nothing the part where the function calls itself with the smaller or simpler inputs. Okay, simpler and smaller inputs are nothing. The value changes here, again it assigns. The values changes here, again it assigns. Like 5 minus 1, 4 will be changed. That way 4 will be going as a parameter. This is nothing argument, parameter. Okay, and 3 will be assigned in this place. Passing a value to this. Passing value to this function. Again, value will be changed. Again, we are passing the value. Again, value will change. Again, we are passing the value. Okay. So this is all about recursive function, and this answer for which question we can write. Okay, that we will see. So I have opened. Before that, let me execute the program and I'll show you the output. So we will take two values. Here we have assigned 5. So let me run the code. So it says that 5 is factorial of 5 is equal to 120. Let me change the value. Let me put 4. Yeah, factorial of 4 is equal to 24. All right. Okay, let me minimize this. So for which questions and all we can write this as a answer. Okay. So let me take the questions. So this is the question I have sent to you. 43 questions we have in this. In this, for 10th question, write C program to pass argument to the function with one example. See, pass argument to the function. So where it is satisfies in this code, you see pass argument. See here we have 4. Okay, this one, this 4 we are passing from this to this. Okay, we're passing from this to this by using function call. So for this question, we can write, which is highlighted with green color. Okay, I have highlighted two questions with green color. For these two questions, we can write this program as answer and you can give the explanation. Okay, so what is the next question? What is recursive function? Explain it with suitable example. This program you can write and you can explain it. And for this also it's applicable. Write C program to pass argument to the function with one example. User-defined function I have given here. Yes, user-defined function. This is user-defined function. Here we have user-defined function which is defined by us. This is main function which is given by the C language itself. Okay, so if you encounter any question in examination, if you see like give one example for user-defined functions, for in that situation and all, you can write this one. Give one example for user-defined function. Yes, you can write this because we have user-defined function here. So we can write this one as an answer for three questions. The first one is write C program to pass argument to the function with one example. The second one is what is the recursive function? Explain with suitable example. The another one is give one example for user-defined function. Any one example for user-defined function. In that situation, you can write this answer. Okay. For three questions, we can write. Let me see any other question satisfies this one. Nested function. No, program to demonstrate recursive function and explain. Yes, we can 39. It is repeating. Demonstrate recursive function and explain it. For this question also, same question only. 29 and 39 both are same. Okay, for this question also we can write. For other questions, list all types of software. No. We cannot list all. No, write a program to pass string. No, write a program final. No. Else if ladder, illustrate function with argument, illustrate function with argument. Yes, write C program to illustrate function with argument. Yes, for this question also you can write this program as an answer and you can give explanation. Okay. Program number 21. What are the categories of user-defined functions? So we have four categories that we have to explain. Okay, in that one of the program you can use this example as answer. What's the difference between structure and union? What is illustrator? What is a user-defined function and illustrate user-defined function and illustrate. Write a program to illustrate user-defined function and explain it. For this also we can write this one as an answer. Okay. Write a program to illustrate single-dimensional arrays with pointers, calculate user-defined derived data types, derived data or derived data of explain it. What are the yeah, this we cannot write because it is similar to this. See, this one is equal to yeah, this one 20 and 12 both are same questions categories, and here user defined function or derivative types in C. Okay, this both are same. You cannot write for this answer you cannot write for this two, and whichever I highlighted with green color you can write this one as an answer and you can give the explanation. So multiple times if you watch this video, then you will come to know many points. Okay, many points you want to write in examination, no? So you can, whatever you can see on screen, if you write this all things, you will get full marks for this question. We can take full marks. See, this all things we have to write along with the program and explanation. All right. So I hope you understood this program and this explanation also. See this video multiple times. It's very simple, easy to understand. So one answer we can give for multiple questions. Okay. All right. Thank you, students.